So I'm going to solve this 2 by 2. It's a linear system with 2 equations and 2 variables, 2 by 2 linear system, first by graphing. And I'm using this one to indicate the limitations of graphing as a way of solving. A picture is worth 1,000 words, but sometimes we've got some messy coefficients here, number one. And number two, the graphing is going to be messy. It's going to be hard to see where these lines cross, if they cross at all. There are 3 options for graphing each of these lines, either finding 2 or better yet, 3 points, a third point as a checkpoint, or finding the X and Y intercepts or slope intercept. I'm going to show the latter 2, both of them, for both lines. So for this first one, if we put in 0 for Y to find the X-intercept, 8 times 0 is 0. 9x minus 0 is 9x. So all you have to do is divide both sides by 9 to get that x is 4. That's our X-intercept for the first line. If we put in 0 for X to find the Y-intercept, 9 times 0 is 0. 0 minus 8y is negative 8y. So I'm not covering up the negative. 36 divided by negative 8. Let's see. I want to say negative 4.5. Going to double check that real quick. Here we go. 6 divided by 8, and it's negative. So yes, negative 4.5 or negative 4.5. Either way. Not as nice for line 2. Putting in 0 for Y, we're going to be dividing 6 by 1/4, which is the same as multiplying 6 by 4. And then 0 plugged in for X to find the Y-intercept. That's going to be 6 divided by 5/3 would be the same as 6 times 3/5. So yeah, 5/3. We're dividing by 5/3, same as multiplying by 5. 18/5, which would be 3.6 or 3 3/5. Okay. On the other hand, since I said that I would be showing both approaches here, let's see here. If I solve each of these for Y to get the slope and Y-intercept, let's see, subtract 9x. And then divide everything on both sides by negative 8. You're going to see that Y-intercept of negative 4.5 or negative 4.5 as the Y coordinate of the Y-intercept showing up again. This one, not as nice. Subtract 1/4 x. And then I'm going to multiply both sides by 3/5, which is the same as dividing by 5/3. going to have to distribute that, just like I distributed the division by -8 up here. Oh, that's Y. Okay, so -3/20 x plus 18/5 or 3.6. All right. So let's take a look at what that would look like. Whether we plot these 2 points and connect, and then these 2 points and connect, or if we plot the y-intercepts and use the slope to find another point. All right, here we go. First, I'm going to plot the x and y-intercepts and connect the lines for each. So, for line 1, plot 4, 0. Got that right there, point A, and 0, -4.5. I'm okay with writing that as a decimal because it terminates. And then connecting. Let's see here. Been a little while since I used this feature, but let me see if I can still do it. All right. So we want to connect A and B here. Okay. Notice that this GeoGebra website gave me the equation. 9/8 is 1.125. That makes sense. All right. And then I'll plot 24, 0 and 0, 3.6. Now that 24, 0, that's hard to see. So I'm zooming out. There it is. All right, going to connect those. Points C and D. And once again, it is giving me the equation of the line connecting them. That matches up with what I came up with there. All right. Now we can see that they are crossing within our field of vision. However, by hand, it would have been interesting enough to plot 0, -4.5 and 0, 3.6. Furthermore, it's going to be tough to tell just where those are crossing. But before we get to that, what if instead you had used the approach of slope-intercept? Now that we know for the first line that 0, -4.5 is the y-intercept, going up 9 units from that and 8 units right, since that's a positive slope. All right, so up 9 from 4.5, and then right 8 of the 0. That didn't do what I wanted. Try again. That didn't do what I wanted either. Just a moment. It might not like me trying to do the arithmetic, but we're going 8 units right of 0 because of the denominator. And then up 9 units from the -4.5. There we go. Notice how that's on that first line. And so similarly, if I start at 0, 3.6. And I want to go, because of the denominator, 20 units right of the 0 and 3 units down from the 3.6, then that is on the second line. But where are they crossing? Because I've already done the question by a different method. I know that where they intersect, the coordinates x is 108 divided by 17, or 108/17, and y is 45/17. Who would have ever figured that out? By the way, let me show one more thing. Notice that it's giving us decimal approximations for that. I want to show you, if you need, instead of improper fractions, if you have mixed numbers, what to do. It may be okay to have decimal approximations at the end. It may be okay to round those at the end. But what if we want an exact answer, but we don't want to see it as an improper fraction? All right, so we had an x coordinate of 108 divided by 17. To get the fractional part for a mixed number, subtract the whole number part of 6, and then press the math button and select the very first option. So that's telling us that 108 divided by 17 is 6 plus 6/17, i.e. 6 and 6/17. 45/17 then. I'm expecting, just like I see on GeoGebra, a whole number part of 2. Subtract the 2. And then convert the rest back to a fraction. So 2 and 11/17. Next, we're going to take a look at substitution. In fact, we've got 2 options for substitution. Now, before we get to solving this by substitution, I want to point out again that graphing as a way of solving linear systems has drawbacks. One is that we can only use it for 2x2 or a little bit with 3x3 when you're graphing either 2 lines or planes. But go beyond 3 variables, go to 4 variables or more. That's how many dimensions you would need. And we're not going to be able to graph that, not going to be able to see that. And then the other, as illustrated by this question, was that it's sometimes tough to tell where they're crossing, if in fact they are crossing. That one, it was. When using substitution, it doesn't matter whether you solve for x or for y, and it doesn't matter which equation. Sometimes there are easier variables to solve for from one equation in particular, like if you have a coefficient of 1 or -1 in front of one of the variables in one of the equations. But we haven't got that here. However, I'm going to take advantage of the fact that we've solved both of these for y. Suppose I take this and plug in for y in the second equation. You have to take a rewrite of one equation and plug it into the other equation. You can't plug this back into this equation. All right, so 1/4 x still, plus 5/3 times what we have for y. I'm going to go back to writing the minus 4.5 as minus 9/2, at least temporarily. And that equals 6. I can reduce 3 into 9. So it's going to give me 15/8 x. Now I still have to distribute the 5/3 to the minus 9/2. I'm going to do the same thing with the 3 into the 9. So 15/2 there. That equals 6. I'm going to add the 15/2 to both sides. But I'm going to rewrite the 6 as 12/2. And I'm going to rewrite the 1/4 x as 2/8 x. And I want to make sure you can see what I have down here. So just a moment. Lower this. All right, you can see that. And after a moment of looking at that, now let's work on this part. Dividing both sides by 17/8 would be the same as multiplying by 8/17. Two will go into the 8 4 times. 27 times 4 is 108. And that's over 17. I'm going to double check since we solved that by graphing as well. Yep, that's what we had for x, 108 over 17. So if I plug that back in here, let's put that into the calculator. 9/8 times 108/17 minus 9/2. Here we go. Going to put parentheses around the fractions. 9/8 times 108/17 minus 9/2. And I can convert that back to a fraction if needed. 45/17, which is what we found for y. So same solution. Another option, by the way, this is not what I normally suggest. However, nothing is pretty about this question. So I could take advantage of the fact that we'd solve both of them for y. That's not a requirement for substitution. If they're both equal to y, then these two things are equal to each other. So I could add the 3/20 x as well as add the 9/2. Our common denominator here would be 40. Our common denominator here would be 10. So we have 51/40 times x equals 81/10. Dividing both sides by 51/40 would be the same as multiplying both sides by 40/51s. And let's see here, 10 into 40, 4 times. And let's multiply 81 times 4 divided by 51. I think I know what's going to happen here, because I know 51 is 3 times 17. So I'm seeing that 17 that we had previously. We had x was 108/17. 81 times 4 divided by 51. There's our 108/17. And same as with the other approach with substitution, if you then plug what you have for x into either one of those where we had y solved for, then we will get that y is equal to 45/17. So now let's, in a moment, we'll take a look at solving this by substitution. By elimination. Solving it by elimination. All right. Well, before we do that, we've already seen the limitations of graphing. What are the limitations of substitution? Again, this got very messy, and part of that was because we did not have a coefficient of 1 or -1 in front of any of the variables in either equation. And worse yet, when we divide, we started getting these not so nice fractions. What else? Typically, substitution is not the best approach to use, particularly when you have more than 2 variables and 2 equations. And I found a website that expresses this idea of what else makes elimination better. It puts it into some better words than I was thinking in the back of my mind, but it's saying what I wanted to say. So let me show you that. All right, I guess it wasn't saying what I thought it was saying. So, I mean, they agree with me, but the reasons they're giving. So let me try putting it in my own words. When you have more than 2 variables, if you don't have one variable isolated in each, where it's the same variable in each of your equations, 3 or more, or at least that you could easily isolate them, that same variable in each of the equations, then you could be going round and round and round, coming up with equivalent equations and nothing simplifying. The idea when you get into 3 variables and 3 equations or more is that you want to boil it down from 3 by 3 down to a 2 by 2 subsystem, and then a 1 by 1, which means 1 equation, 1 variable. And similarly with a 4 by 4 system, all of the 4 by 4 linear system would mean you have linear equations with 4 variables each, and you would have 4 equations, and you want to go from a 4x4 system to a 3x3 system, subsystem, to 2x2, to 1x1. And then once you have that one variable, you've cracked it. You can go back and find out the other variables. All right, so let's see this same system being solved by elimination. A little too far. All right, let's erase this stuff. All right, magically erased in just a moment like that. Okay, so remember, none of these numbers are particularly nice. I'm going to use the first equation to get rid of x in the second equation. What I'm going to do is take and multiply by 136, negative 136, in fact. Multiply equation 1. I'm going to abbreviate equation 1 by negative 136. And add that to equation 2. Now, 9 times negative 136, that's going to reduce to negative 1/4. I've also got to multiply it to the y term and to the 36 constant on the right. So negative 136 times negative 8, 836, which will reduce to 2/9. And then this is going to be negative 1. 36 times negative 136 is negative 1. Okay, if I add that to equation 2, the x terms will cancel because they are where we've got the coefficient, same in absolute value, but opposite in sign. 2/9 y plus 5/3 y equals negative 1 plus 6. That's going to give us 5. Okay, common denominator, 9. So I'll multiply top and bottom by 3 here. That adds up to 17/9 as our coefficient of y. Multiply both sides by 9/17. And that gives us that y equals 45/17. And got just below where you can see. So let me bring this back down. That's the same that we had for y in the other approach. Double checking that real quick. Yes. All right. So if I plug that in to one of the equations, we can find x as 108/17. How about we plug that into the first? Since we've already got a fraction, let's save the other mess of the fractions for a bit. Eight times 45. Want to say that's 360. Let's see here. add that to the 36. Get a common denominator there. 36 times 17 is 612. So when I add 360/17 to 612/17, I've got 972/17. Instead of saying that I'm going to divide by 9, I'll multiply both sides by 1/9. Let's get this out of the way. And 9 will go into 972 108 times. So there's the same x coordinate we found by graphing, by substitution, and now by elimination. But we're going to take one more step. And although it'll continue to use elimination, it's going to be written a little bit differently. And hopefully it's going to make, even though we're still going to have some messy fractions, it's still going to make things easier.